Welcome back, folks. In this video, we're going to talk about how you can create the equation of a parabola given, in this video, some random point and the vertex. And in the next video, we're going to talk about how you can do it with the x-intercepts. Eventually, we'll be able to do it with just a bunch of random points, but we won't get there quite yet. Alrighty, so I have the vertex and some random point. Now, what's nice about this is that we actually have a certain form of the equation that utilizes the vertex. For example, let's think back to linear functions. With linear functions, we have standard form, which is not particularly helpful, but we also have slope-intercept, and then we also have point-slope. Point-slope. So slope-intercept would be y equals mx plus b. Point-slope, y minus y1 equals m times x minus x1. Just a little refresher there. Now with quadratics, we actually have vertex form, which is y minus k, where again k is the y coordinate of the vertex, equals a times x minus h squared, where again h is the x coordinate of the vertex. These are very, very similar, and you can think of a vertex form as the point slope form, quote unquote, just for quadratics, because they are nearly the same. It's just now it's that x quantity squared, whereas in the linear function it's just raised to the first power. And we also know from our discussion in class that a performs a similar function on the graph as the slope does for a linear function. But anyway, let's take a look now at how we can actually use this to get the equation of this parabola, or this quadratic. Now we know the vertex is at 5, 7, so we can throw that in here. Okay, so I know y minus 7, because 7 is the y coordinate of our vertex, is equal to a, which we don't know yet, times x minus 5 squared. Okay, this is very similar to what we would have done with a linear function, where, okay, I have most of the information, but I'm still unsure about what this missing parameter is, what this coefficient or constant is. Well, this is where we need to use that other piece of information, where in this specific case, hey, when x equals 3 in this parabola, I know that the y value is -4. And so all we need to do is just throw those values into here, and we'll have everything we need to find a. So so we'll throw in -4 for y. -4 minus 7 is equal to a, again, we still don't know what a is, times 3 minus 5 squared. Let's clean this up, so we'll get -11 here, equals a times, let's see, it'll be 3 minus 5, which would be -2. We square that, we'll get 4. And therefore a must be -11 over 4. And so when it's all said and done, our equation for this parabola is y minus 7 is equal to -11 over 4 times x minus 5 squared. If we wanted to, we could also move everything over to one side, multiply it out, and get it into standard form, but otherwise we could just leave it there in vertex form.